Two tugboats are attempting to free a barge that is stuck on a sandbar and are exerting the forces shown in the figure. Find the magnitude and direction of the resultant force. In other words, how is the boat coming off the island if these two tugboats are pulling on it? Well, if we could, let's move our axes to sit right on top of this. The two forces acting together mean that we really just want to add the two vectors. Well, if you remember, vectors are a lot easier to add when they are in either this form or the IJ form. So we want to convert how they are now to something that's a little more workable. So I'm going to call this tugboat number 1 and I'm going to call this tugboat number 2. So for tugboat number 1, I see that the angle here is 35 degrees and the force, not the resultant, but the force is 1500. So the A part of this will be 1500 times the cosine of 35 degrees, and the B part of this will be 1500 times the sine of 35 degrees. All right, so we'll write down what each of those is. So for A we have 1228.7, and for B we have 860.4. So this would be the horizontal component force, and then here's the vertical component force. So I'm going to write that in terms of I and J. 1228.7 vector I plus 860.4 vector J. All right. Now let's come over here and do tugboat number 2. I'm going to want its A component, its horizontal component, and its vertical component. Now we've got to be careful about what is this angle, because remember when we're naming an angle in terms of magnitude and direction, we know its magnitude is 2000, but what is this angle? Well, we've got to come from 0. I am told that between these two is 90. Then I have another 35, so the whole angle is going to be 125 degrees. So for A, it'll be magnitude times the cosine of the angle, and for B, or the vertical component, 2000 times the sine of the angle. So for the horizontal component, it's negative 1147.1, and vertical is going to be 1638.3. In IJ form, negative 1147.1 vector I plus 1638.3 vector J. So we need to add the two tugboats together to get their resultant force and magnitude, to get their resultant magnitude and direction of the force. So when we add the two vectors, we will add the corresponding parts together. So we'll add the horizontal components together, we'll add the vertical components together, and find the resultant. So we end up with 81.6 in a horizontal direction plus 2498.7 in the vertical component. So slightly, not a lot to the right, but quite a bit vertically, which is what we would probably expect in this picture. Now we want to find the magnitude and the direction. So this is the answer in IJ form, but we are asked for the magnitude and the direction. So the magnitude of the vectors will be the square root of 81.6 squared plus 2498.7 squared, which is equal to about 2,500, and that was newtons, so about 2,500 newtons of force. And then we will do the tangent of theta is equal to B over A, so 2498.7 divided by 81.6, and we will do the inverse tangent of that. And we get 88.1 degrees when we do that. Now we do have those quadrant considerations, so you might think, well, how do we know that it's not going to quadrant 2, because it really is pulling off so close to vertical away from there. You might have some questions as to whether it's in quadrant 1 or quadrant 2. Well, I kind of went past this quickly earlier, but we have a positive positive. So positive positive tells me I am in quadrant 1. And since my tangent is positive, quadrant 1 and quadrant 3 are my only options. Quadrant 1 it is, so there's the angle. So this has the resultant force has a magnitude of 25 newtons in the direction of 88.1 degrees. But of course, there's always these bearings and things that we have to deal with. So if we want to give our angle in terms of a bearing, now it didn't specifically say that, but I think it would be a good thing to practice in case you have one that does. 88.1 degrees, just because I'm getting kind of tight with drawing up there, is right here. So that would mean I would want to start at north and go to the east. So it would be north, and then 90 minus 88.1 would be 1.9 degree. So north, 1.9 degrees east, if we were asked for it in terms of a bearing.